In today's video and class, we are going to look at ascending and descending chromatography, which happens to be types of chromatography that are often used in paper chromatography and in thin layer chromatography. Let's start by looking at the ascending chromatography. So ascending chromatography is a separation technique in which the mobile phase, which is the solvent, travels upward by capillary action against gravity through the stationary phase to separate sample components due to their differences in affinity for the stationary phase. And one thing that we have to note in that in paper chromatography, a sheet of paper coated with cellulose is used as the stationary phase, and also in thin layer chromatography, a glass or a plastic plate coated with silica gel or alumina is used as the stationary phase. So now let's look at this diagram over here and study it. So this diagram shows two setups, with the first setup showing the beginning of a chromatographic process in paper chromatography, and the second setup showing the end process of the paper chromatography. So in the beginning process, we have our stationary phase, so which is the cellulose filter paper here, spotted with our test sample, which is the ink spot, and supported with this rod to stand upright in the chromatographic chamber as shown over here, containing our solvent, which is serving as the mobile phase. The second setup, as shown here, which is the end process of the paper chromatography, shows how the various components, so these are the various components of the test sample. So this is the spotted test sample, are separated as the mobile phase moves upward by capillary action through the stationary phase. And these are the separated components of our test sample, with this component being the least soluble compound in the mobile phase and the most adsorbed compound to the stationary phase, and this separated compound being the most soluble compound in the mobile phase and the least adsorbed compound to the stationary phase. Now let us look at some key features of ascending chromatography. We'll start with the stationary phase. So what we have to note is that the stationary phase in thin layer chromatography is mostly an adsorbent material like silica gel or aluminum spread on a flat surface of a glass or a plastic plate. And in the case of paper chromatography, it's a cellulose filter paper which is chemically inert and has a wide range of pore sizes. And what we have to note again is that both the silica, the alumina, and the cellulose are polar and adsorbent materials and are compatible with many solvents. So this property makes them ideal to be used as a stationary phase in chromatography. So the next is the mobile phase. So the mobile phase is the solvent or the solvent mixture in the chromatographic chamber or column that separates the different components of the test sample through the stationary phase as it rises by capillary action. So let us take a look at this setup over here, and this is a setup showing as ascending paper chromatography. So this is our chromatographic chamber containing our mobile phase as a solvent over here, and this is the stationary phase, which is a cellulose filter paper supported in the chamber with this rod over here and this clip over here. This is our spotted test sample over here, and these are the various components separated as the mobile phase moves upward by capillary action through the stationary phase. So now let's look at the separation mechanisms. Different components of the test sample interact differently with the stationary phase and the mobile phase, leading to varying rates of movement. And components that are more soluble in the mobile phase will move further up the stationary phase, whilst those that are more strongly adsorbed to the stationary phase will move less. So if we should see this component being separated over here, so we can say that this component is more soluble in the mobile phase and therefore will move further on the stationary phase, whilst this component over here is adsorbed much more strongly to the stationary phase, hence will move less on the stationary phase. So the next is visualization. What you have to note here is that after the solvent front has moved a certain distance, the separated component can be visualized using various techniques such as UV light, which will allow you to see the compounds that absorb to UV radiation. We also have the iodine vapor for detecting unsaturated compounds, and we also have an anhydrine for detecting amino acid, and serum molybdate stain, which is used for a wide range of organic molecules or by visually observing color changes. So these are some of the visualizing agents that are normally used in chromatography. Now let us look at the applications of ascending chromatography. One, for qualitative analysis. So ascending chromatography is often used to identify the components of a mixture based on their RF values, which is the ratio of the distance traveled by the compound to the distance traveled by the solvent, and it is also used in purification process, and it can be used to isolate specific compounds from mixtures for further analysis or use. Also, we have two types of ascending chromatography that are often used in the paper chromatography and thin layer chromatography. And these are the one-way ascending chromatography and two-way ascending chromatography. So we'll start by looking at the one-way ascending chromatography. One-way ascending chromatography is a type of chromatography where the solvent moves upward through a stationary phase to separate the components of a mixture, and it's commonly used in paper and thin layer chromatography. So let's see how it works using the paper chromatography. So first, a test sample is applied on the baseline of the chromatographic paper. So this is our chromatographic paper, which is acting as our stationary phase, and this is our test sample applied on the baseline. So the chromatographic paper is suspended in the chromatographic chamber with the solvent, which is the mobile phase, at the bottom. The solvent, which is the mobile phase, moves up through the chromatographic paper by capillary action, and as this happens, the most polar or the most adsorbed substance, so which is the red substance over here in the mixture, moves slowest and end up at the bottom of the cellulose filter paper or the stationary phase. And the least polar or the least adsorbed substance, so which is the orange substance seen over here, moves the fastest and end up at the top of the cellulose filter paper or the stationary phase. Now let's look at the two-way ascending chromatography. A two-way ascending chromatography is a chromatographic technique where a sample is separated twice using ascending chromatography in two different solvent systems, essentially running the chromatography process first in one direction with a specific solvent, then rotating the stationary phase 90 degrees and running it again with a different solvent to allow for better separation of complex mixtures. So this technique is basically used for separating complex mixtures where components might have similar retention factors in a single solvent system. And this technique is often called two-dimensional chromatography in the context of thin layer chromatography. So I'm going to use this picture over here to explain to you how the two-way ascending chromatography works. And this picture over here has three setups with setup A and setup B and setup C. So the setup A shown over here and setup B happens to be the first ascending chromatographic techniques where our spotted sample in setup A is separated into its various components as shown over here in setup B after allowing the mobile phase to run upwards through the stationary phase. So before we continue with the third setup, I would like to interpret the chromatogram or the results over here. So as we can see, we have five components being separated. So with this being the first component, the second component, the third component, the fourth component, and the fifth component. But one thing we can also see over here is that the second and the third components are complex mixtures because they have almost the same RF value. So we can see that they are very close to each other. And the fourth and the fifth components also happens to be complex mixtures having almost the same RF value. So to be able to separate these complex mixtures, that's component 2 from 3 and component 4 from 5, we have to allow the chromatogram in setup B to air dry completely and then rotate the stationary phase 90 degrees clockwise and run it again in a different mobile phase or solvent to allow for better separation as shown in setup C over here. So one thing that I also like us to look at, so we can see that the mobile phase over here in setup A and B has the same color, but that of setup C, which happens to be a different mobile phase, has a different color over here. And also, if we are to rotate the stationary phase 90 degrees clockwise, we can see that the analyte, which is the drop of the mixture over here, will be here, and the first separated component, which is a pure component, will also move up over here, giving us one separation. Now the second and the third components that I would say are impure will also be separated over here nicely, and the fourth and the fifth component will also be separated here nicely. So this is how a two-way ascending chromatography is done in the laboratory. Chromatography. Descending chromatography is a chromatographic technique where the mobile phase moves downwards due to gravitational force to separate components in a mixture. In these techniques, the paper is dipped into the solvent or the mobile phase, which is present in a trough or a tank near the top of the chromatographic chamber and supported to stand firmly in the chamber. So if you should look at the first diagram or setup over here, this is the chromatographic chamber, and this is the stationary phase, and this is the tank containing our mobile phase. And this is where we will be spotting our test sample over here. So once we spot our test sample and dip the stationary phase into the mobile phase contained in the tank, The mobile phase will move downwards due to gravitational force, and as it moves downwards, it will separate the various components of our test sample. And the second diagram or setup over here also explains the same thing, where this happens to be our chromatographic chamber, and this is the mobile phase tank, and this is the lid of the chromatographic chamber, and this is our stationary phase, and this is our mobile phase over here. So what happens is that we spot our analyte over here and support our stationary phase with a paper support over here. And once we support it and dip it into the mobile phase will move downwards due to gravitational force. And as it moves downwards, it will separate the various components of our test sample as shown over here. So this is the first component, and this is also the second component of our test sample, and this is the movement of the mobile phase. So these are some questions I would like you to try your hands on before coming into the lab. 1. State 3 properties of chromatography paper and TLC plate that makes them good for stationary phases in chromatography. And 2. Describe the chromatography chamber and state its importance in chromatography.